So now let's look into the algorithm development part. One of the key things which will be used in every machine learning project, or this is a way of actually sort of applying the machine learning algorithm over to some data. And again, we'll know about how to process this data and how what to feed to our model and how to evaluate the model and how to check basically how good our model is. So we'll be learning all of these things in our algorithm development section. So the first thing which comes with the machine learning is the data. The data is a collection of data points. In case of tabular data, a data set corresponds to one or more data tables where each column of table represent a particular variable and each row corresponds to given record of data set. One of the most famous data set to start with is the iris data set. It is a flower. There's a three type of flowers, and then there are some features like the sepal length, the sepal width, the petal length, and the petal width, and then finally the name of the flower. So we have these four features according, and they are they are being recorded for different flowers, and then finally we have the class label, which is the name of the flower. We have 150 such data points, which means someone recorded the information about the sepal length, the sepal width, the petal length, and the petal width of particular flower and noted it down in some sheet. And now our task will be to actually create a model which will be able to distinguish, or you'll use regression to create more points. But first, let's try to understand with the classification. Will our task will be sort of like we have these features, these four features, and then we would want to predict what actually the real flower would be. So according to this 150 points, we'll try to model our machine learning model. So before that, let's see what are the prerequisite. So to create any model, we have to go through a phase of training and testing. As the name suggests, training is a part where we'll be training our model, and the testing is a part is where we'll be testing how good the model is. Because the model works only with the data, we need to split the data into two sets, a training set and a test set. Train, this division is mostly done using 70% of full data is used as a training set, and remaining 30% of the data is used as a test set. Suppose we have 100 rows of data, or the 100 rows information, then we'll only use 70 rows for training the model, and then we'll use these 30 rows to actually test how good the particular model is. So this is the way we divide our training and testing set, uh, is a way of actually finally modeling our problem. So while training will note that while training we only give the model the training data, and while testing we only give it the test data. And the training data and test data should be different. Nothing should be common in between these two sets. They should be separate from starting, and like this is how then we'll achieve the best result in our model. So further in a video, we'll be following this iris dataset, and we'll be using the sklearn to actually load this data and to use all those algorithms which we'll be learning later. So for now, let's start with actually seeing how we can load this data first, and then see what is there in this data and how we can process the data. So let's just open our text editor here, and I'll create a new file, maybe main.py, and inside this So let's start with importing the libraries from sklearn.datasets import our load iris function, and let's also import the pandas as pd. So our data, let's just call this load iris function, then our data will be loaded in our data variable. Let's just try to print what is inside our data, and we'll do this using our control plus tilde keys, and then we'll write Python 3, then the name of the function, name of the file. So we see there's a lot of information inside our simple data variable, and it's sort of like a dictionary where inside the dictionary the data key has some array of information, which is our row, which are our four features which we want, and then there's some target which have uh, the value of the class, sort of all the name of the flowers in as a integer in our class saved as a target, as a key of target. Now I will be using data frames from pandas to actually import the data and make it look like a table as we saw in our slides. So we'll have this df as data frame pd dot data frame, and then our data is inside the key of data, so we'll use that, and then we want to give this these because the data did not had any columns, it's just the raw data. There's no name to our columns, but later if you see inside that our feature names, there is the name of all the features. It's inside this dictionary, but take it for granted. Inside the key of features name, we have the column names. So we'll use that data, and here we'll use feature names. Then we have, let's just try to print what we have in our data frame. Let's try to print it again. So now we have some features, and it's not showing every column, but as you can see here, it has 150 rows and 4 columns. It's only showing this sepal length and a petal width, which was the last feature. So we have imported the 4 features which we wanted. Now let's also try to import the targets. So write, we'll add one more column to this data frame, which can be of species of that particular flower, and then data, which is a dictionary, and in that dictionary we saw earlier the target key has that all the information. So we added that also. Now let's try to print our data frame. We'll try to print it again. As you can see, now we have 150 rows and 5 columns. The last column will be our species here. If you can see, this is the last species column, and it will be the class or the flower name in short. Let's try to use df.head. That would give us a better results while printing. So in the df.head we had only 5 rows, and it's showing us only 5 rows, and it's sort of like that. We have the 5 features, the 5 columns where 4 are the features, and the last one is our actual class of that flower. So this is how you load the our data set, and if I slide it here, so right now what our data frame is looking like is exactly at this state where we have all the features, the 4 features in our um, columns, and the last column of species has that class integer, where the 0 represents one class, the 1 and 2. So there are total three classes and they are in the integer form. So all the algorithms which later we'll be using, this is how we import the data from sklearn. So let's get ahead. The next point which we want to know is actually for all of the machine learning tasks, we need to set the targets as y, some sort of like we are trying to predict the value of y given the value of x. This just make it every problem look simpler. So we reduce every machine learning problem in this basic example of we are with the value of x, we are just trying to predict the value of y. So here the value of x is not just one value, it's a vector. And what does that vector made up of? The vector is made up of the four features. According to that four features, we'll be trying to predict or to do all the classification or regression or clustering, all of this in the on the base of these four features. And the y values are the values of the target. So let's try to get these x and y values, and then we'll use one of the function of sklearn, which is train test split, which does the same thing we talked earlier. We need to divide our testing and training data, and that test train split does the same thing. It just give us our two sets. One is training set and one is test set. So let's look into the code how we can do that. So right after we have imported all of our data, now first thing we need to import that train test split from sklearn. So sklearn dot model selection import this train test split. Let's close this. And now our x, which we talked earlier, is nothing uh, but these four columns. Now let's first thing, let's just drop our column names, otherwise they will be inside our data. So let's drop the species, then the left will be all our four features, and then we'll have that as our x. So let's just drop that species column, then the left all of these features, that will be nothing but the x. Then our y is nothing but just the species column. So the y is nothing but the species column, and the x is everything minus that species column. So we just divided our x and y like that. Now we need to give the four variables which will be storing our training and testing data, and each training and testing data needs to have an x and y values. So let's say x train, then we will have x test, then we have y for all the training targets, and then y for test as our test targets. And this is equals to our train test split. There we give our capital X and capital Y's the full data, and then within a feature of test size, this will take the ratio of how what percentage of test size do we want. We earlier talked about 70-30 percentage division. We can also choose 80-20 percentage division. So now, because we have given the test size to be 0.2, our X train will be 80% of the full data, and our Y train, our X test will be of only 20%. So X train will have all the features, all the 80% of the features, the four values, and Y train will have the corresponding targets. Similarly, the X test will have the 20% of all the four features, and Y test will have the corresponding target values. So here, while training our model, we'll only give the X train and we'll try to make it predict the Y train. While on testing, we'll give it only X test and we'll try to see how good the model was on the basis of how close it was to a Y test. So this is how we divided the model, divided the data before supplying it to the model into the two parts, the train part and the test part, using the train test split. Finally, we come with the evaluation part. Now suppose our model, which was to classify, uh, for example, only a spam email or not. So we suppose we have a model which classifies our all our mails as in either they are spam or they are not a spam. Then how can we evaluate how good our model is? So there's something called confusion matrix. There we have these four this matrix which have four values for binary classification, where we have a true positive, false negative, false positive, and true negative values. What are these values? So let's say the mail was spam, and the model which we used for classification predicted it to be spam. Good and good. So it was true positive. It was uh, our model was truly gave the results which we wanted. And this section where the actual prediction and the actual class and the predicted class are the same, then it's called true positive. Similarly, if the mail was not a spam and we detected it as a uh, and we also predicted as the model also predicted it as a not a spam, then that is a true negative. It is not a spam, true negative. And and then in the matrix we have two more columns. What happens when the mail which was it was a spam, but our model which was classifying it as a spam or not, it classified it as not a spam. This is what we don't want. We don't want our mails to be going into our non-spam folder. This is called false negative. Similarly, if the mail was not a spam, but our prediction was that the model predicted that the mail is a spam. Now it is called false positive. So according to these four values, we have different mathematical features which are used to actually calculate how better one model is from the other. Let's look into that. So first thing is the precision, how precise our model is. And different in different times we'll use different mathematical features to actually score our models. One of the most common feature is accuracy, how accurate our model is. This is nothing but adding the true positive and true negative, which means when it is a spam, how many times we gave it as a spam, and when it was a non-spam, how many times we gave it as a non-spam, total upon total number of times there was mail. This is one of the most simple way of actually judging our model. But in different uh, type of data, we might need different features to actually judge our model. So one is precision and the other is recall. Precision is how much is our true positive upon true positive plus false negative, which means how precise we are in detecting the spam as a spam. When our model is something like very precisely trained to be only be good at dividing the mail into spam, how good it is in detecting the spam only. Similarly, we have a recall, which is true positive upon true positive plus false negative. And at the end, we have the F1 score, which is quite popular in all of the classification models. This is one of the standard mathematical features which is used to judge how good one model is from other. We do not want a model to be fully precise. We don't want it to be fully recall. So F1 score gives us a best picture about all of the model. F1 score is 2 times into precision into recall upon precision plus recall. So you will hear about the F1 score a lot in the classification models. So this is how we actually judge finally how good our model is.